Well, greetings, everybody. So here's a problem from our assignment in my math lab, and it's from the assignment that has a lot of questions that are geometric series. And I think when you first read this one, it doesn't seem like it fits. It doesn't seem like there's a series necessarily, and that it's a geometric series especially. But who knows? Maybe some people look at this and they think it's real obvious it's a geometric series. I think you're probably more used to seeing questions like this one, where there's obviously some numbers that are added together, and we can find out that there's a pattern that if you take any number times 1/5, you get the next number in the series, and then that pattern continues. That's a geometric series. But this one, at least it doesn't appear like the other questions. But let me show you why it is. Okay, so it says that we take a dose of 160 milligrams of an antibiotic every 4 hours, and the half-life of the drug is 4 hours. So by the time you take one dose, the dose you've already taken is such that half of it remains circulating in your body. Okay, so I might say I take this first dose of 160 milligrams, and in 4 hours, among that pill I swallowed, among 160 milligrams of antibiotic that I consumed, 80 milligrams of it is still circulating around. So question is, can you find the long-term steady state amount in your blood? Okay, so yeah, I'm going to take some, it's going to deplete, but I'm going to take more, and then that's going to deplete, and then there's going to be some kind of long-term balance with that. All right, that's what they mean by the steady state amount. So let's look at it like this. I think this problem is probably easiest to do just by writing down what it looks like is going to happen and see if we can find a pattern. So I have a little chart, and I have the dose here in this column and the amount that's in the body at that dose. Okay, so when I take that first dose of 160 milligrams, that's how much is in my body that moment that I swallowed that pill. Okay, now by the time the second dose comes, half of that first dose is remaining. So I took 160, but by dose 2, half of that, which is 80, is in my body, but then I add another 160 when I take that second dose. So that's how I'm looking at dose 2 right here. Half of dose 1 is in there, plus all of dose 2. Now we would just have to repeat that, because by dose 3, half of this amount, because the half-life is such that whatever amount is circulating in the blood, whatever that amount is, in 4 hours, half of that's going to be there. So in parentheses, I have the half amount. So I take half of 180 plus 160. That's going to be 40 and 80 plus another 160. Okay, so that's at the moment I take dose 3. Now I half all this, half of 40, half of 80, half of 160. That's how much is left over from the previous dose plus another dose of 160. And I just keep going, okay? Now, notice I did not calculate any of these because I want to see a pattern. I want to see that, like, if I keep this up, these numbers as they are individually do make some kind of pattern. They're not random. There's a definite pattern to 160, 80, 40, 20, 10, for example. Okay, so I've written this chart up all through dose 5. Now, I do see a pattern. Okay, I'm going to write it. It seems to be that the series is expanding in this direction, or as you're looking at it, that direction. Okay, but I'll write it like this: 160, 80, 40, 20, 10, and so long as I'm confident at this point that that's going to continue, I suspect the next number will be 5, and then 2.5, and so on and so forth. So what I'm looking at here is that this dosing schedule as you go out to infinity, okay, is going to be a geometric series. First term is 160, and then the comma ratio is a half. Okay, multiply any term of this series by a half, you'll get the next term. All right, so a geometric series like that converges to the first term, 160 over 1 minus r, 1 minus 1/2 in this case, and that's 320 milligrams. So that's why they can say that this steady state amount is 320 milligrams. All right, one more thing. You might say, we're not going to take a drug to infinity, like realizing that actual infinity is not possible. How is this applicable to what would really happen? And to that, I would say that, well, I mean, yeah, we'll not take it to infinity, but you might see that it doesn't actually take very long for this series to level out to being extremely close to 320. So rather than take it to some arbitrarily far point, we can take it to infinity and say we get 320. And then, yeah, once you take it far enough, that's basically what you're going to get. Okay. So, yes, despite appearances, it's a geometric series, okay? Even though it didn't sound like it when we read it, we might see that it's not so different than this one, okay? That's another geometric series. It turned out to be basically the same thing, and I might even say with much simpler numbers.